As we learned, the 8086 microprocessor has two functional units: EU, execution unit, and BU, bus interface unit. Let's dig a bit deeper into it. The execution unit offers instruction to BU, expressing from where to fetch the data and then decode and execute those guidelines. Its capacity is to control activities on data utilizing the guidance decoder and ALU. EU has no immediate association with system buses. It performs activities over data through BU. Let us now discuss the functional parts of 8086 microprocessors. ALU. It manages arithmetic and logical operations, like plus, minus, times, slash, or, and, not operations. General Purpose Register. There are 8 general purpose registers, i.e., A, AL, BH, BL, CH, CL, DH, and DL. These registers can be used individually to store 8-bit data. It also can be used in pairs to store 16-bit data. The valid register pairs are A and AL, BH and BL, CH and CL, and DH and DL. It is referred to as the AX, BX, CX, and DX respectively. AX register minus it is also known as the accumulator register. It is used to store operands for arithmetic operations. BX register minus it is used as a base register. It is used to store the starting base address of the memory area within the data segment. CX register minus it is referred to as counter. It is used in loop instruction to store the loop counter. DX register minus this register is used to hold the I/O port address for I/O instruction. It is a 16-bit register. It holds the address from the start of the segment to the memory location. A word was most recently stored on the stack. It is a 16-bit register that behaves like a flip-flop. It changes its status according to the result stored in the accumulator. It has 9 flags and they are divided into 2 groups minus conditional flags and control flags. It represents the result of the last arithmetic or logical instruction executed. Following is the list of conditional flags: minus, carry flag, auxiliary flag, parity flag, zero flag, sign flag, overflow flag. Control flags control the operations of the execution unit. Following is the list of control flags: trap flag, interrupt flag, direction flag. BU takes care of all data and addresses transfers on the buses for the EU. EU has no direct connection with system buses, so this is possible with the BU. EU and BU are connected with the internal bus. It has the following functional parts: minus instruction queue. BU contains the instruction queue. BU gets up to 6 bytes of the next instructions and stores them in the instruction queue. When the EU executes instructions and is ready for its next instruction, then it simply reads the instruction from this instruction queue, resulting in increased execution speed. Pipelining. Fetching the next instruction while the current instruction executes is called pipelining. Segment register min. View has 4 segment buses, IECS, DS, SS and S. It holds the addresses of instructions and data in memory, which are used by the processor to access memory locations. It also contains one pointer register IP, which holds the address of the next instruction to executed by the EU. CS- it stands for code segment. DS- it stands for data segment. SS- it stands for stack segment. S- it stands for extra segment. Instruction pointer minus. It is a 16-bit register used to hold the address of the next instruction to be executed.